Okay, so this is going to begin our next adventure into logs, and I wanted just to clean up some of the things that we have been viewing videos and practicing and whatnot. And we're going to leave some of these properties till later. We'll cross that bridge when we come to it, but I really just want to spend a moment and make sure that we know a few more things about logs before we begin here. Okay, so something that we want to keep in mind is that I know in the videos and all the other stuff we were using logs of bases, and it might have been like log base 5 and etc., etc. Well, for this particular going forward, there's two types of logs that are commonly used. One of them is a common log, but the one that I use is a natural log. And just to explain a little bit about what they are, I said if I have a log and it is a common log, x equals y, the default base is going to be the 10. And so using the definition of a log, we can go 10 raised to the y power equals x. Okay, so it's implied there. It's not written. So if any time you see the log and it's written like that, the base is going to be 10. A natural log, though, is ln. I should write it ln, and of x equals y, and this is going to be the base of e. E we discovered in our earlier lessons and assignments, and we can rewrite this as e to the y equals x. If you remember that e is going to be approximately 2.718, and that goes on forever. Okay, so all that's pretty important information, and there are the main focus of what we're going to be looking at with these next couple bits here are going to be all of these guys. And we're going to learn how to expand these logarithmic expressions first, and then we're going to learn to condense them, and then we're going to be using them in various ways. So let's move on to the first part here. So we're just looking to expand. That means rewrite this, break it apart into different pieces. All right. So what I'm going to do is that I look at this and I say, all right, well, this is going to be 4 times the square root of x. So if I'm multiplying that, I notice that I have a product rule for logs. So anytime that I take the natural log of something that is being multiplied, I can break it into 2 different parts, like this. All right. And so that would be our first step. Now, oftentimes, we want to look for exponents as well. And exponents are rewriting things that in an exponential power, so we might be able to expand the logs even more. So for example, if I look, this 4 can be rewritten as 2 to the second power plus, and if you remember from our adventures earlier on in the year and your math 2 days, is that the square root of x equals x to the 1/2 power. And that's going to be important in a minute. So now that I have all the exponents kind of in a spot where I can apply this property right here, this is the way that we're going to do it out. So the 2 comes out in front here, and the 1/2 comes out in front here, according to the property, and we get 2 natural log of 2 plus 1/2 natural log of x. And this is going to be our most expanded form. Okay, after you just kind of do a quick check, is there any other properties that I can go ahead and apply? If it's no, then you know that you are in good shape and the log is fully expanded. This next guy is going to looks like it is a fraction, and fractions are quotients, and so therefore we're going to use a quotient rule on this guy. And this basically means is that if I have something I'm dividing, I can break them up into a difference, which the top part, okay, so that means the numerator here has to go first, and then the denominator. All right, so that's broken up using that property. Now we scan on over for some exponents, and it looks like we have a 3 that could come out in front, and that's good news. So we got 3 ln e minus ln x. Now we also have a property from, if we look up over here, from our other videos that we watched, that ln e is actually 1. Okay, so we have 3 times 1, which is just going to give us 3 minus ln x, and we are done. We're in good shape. Okay, so that's how you go ahead and knock those guys down. And this next one, we're kind of combining a little something for everybody here. And the first thing I want to do is that I look at that as a quotient. It's got that big division bar, so it kind of screams use that quotient rule. And I'm going to get ln, oops, I like to put everything in parentheses, minus ln of x to the 4th. I think that's to the 4th. I can't really see. And so if it's not, then you'll have to change it. So y to the 7th. And I look at that and I'm like, okay, there's some stuff going on here that I still can break things down. I can break down this part right here because that is now going to be a product, and I know that I can change that into a sum. So I'm going to go ln 9 minus, and I'm going to go ln x to the 4th power minus ln, oops, take that back, it's not a minus, plus ln y to the 7th. All right, and end that up. Now notice that if there's a minus sign, okay, that guy, and you're going to apply another property, which I did right here, it has to be set off by those because I'm subtracting that entire sum. All right. So now I'm like, all right, well, I have some exponents, and I could rewrite this guy. I'm gonna do some cleanup here. I'm gonna rewrite this 9 exponent, and I'm gonna distribute this negative in first. So I'm gonna go 3 to the 2nd power minus, I'm just putting the negative signs in, okay, or multiplying by -1. Okay, and that looks so far so good. And now I can deal with all those exponents. They can come out in front. So the 3 comes out in front, that 4 comes out in front, and that 7 comes out in front. So this is going to give me 2 ln 3 minus 4 ln x minus 7 ln y. And now I'm all done. And so that's how you do that one. More steps than usual, but once you start developing a nose for it, you'll be able to knock them down quite easily. Okay. Now, I designed this last problem kind of like looking at, well, how do I know when I'm done sometimes? Okay. And so if I look over here, this is a mistake that a lot of students make. All right. And so they'll go and they'll go, all right, this and this. And we love the distributive property because that's one of the first things that we learn. And students think this is incorrect, so don't write this down thinking this is good information, okay? And that would be correct, but it's not. The only way that this could be broken apart is if this were a fraction, which is not. So this is bad, all right? So don't do that. This, we just leave it alone. So, leave it. But this guy has some hidden terms, okay? Or I should say a hidden attribute. So if we remember, we got that x squared minus 9. And if we remember the difference of squares, we can rewrite that as x squared minus 3 squared, which we can break up into x minus 3, x plus 3. So I have ln, and I'm going to use these brackets here. Oops. X minus 3, x plus 3. And now I have those two binomials, which are right here, being multiplied by one another, and I can apply the product rule over here. So I'm going to go ln x minus 3 plus ln x plus 3. Okay, so that's kind of our beginning part here of the log lesson, and I'm going to be throwing the assignment in your direction real soon, and make sure you get some practice with that, and then we're going to move into condensing the logs and using other properties to do things with them. So that's how you do that, and yeah, see you next time.